radicals and rational expressions. So the first thing here, they ask us to convert to mixed radicals. So when you're doing questions like this, we're dealing with square roots and cube roots, and I'm just going to keep it between the square roots and the cube roots. There are lots of ways to do these kind of questions. I'm sure you've seen different ways of approaching this. The way I like and the way I prefer is, I know my perfect squares, so I'll just list them out for you here. So the perfect squares are 4, 9, 16, 25, 36, 49, 64. And how I know that? Because 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. And then the perfect cubes is 8, 27, 64, and so on. That just means 2 to the power of 3 is 8, 3 to the power of 3 is 27, 4 to the power of 3 is 64. So you remember that the square root is the opposite of a square. What does that mean? It means when I say square root of 25 is simply 5, square root of 81 is 9. And if I'm doing a cube root of 27 is 3, a cube root of 125 is 5, and so on. So if you want to convert numbers to mixed radicals, so the first thing, since this is square root of 75, definitely 75 is not a number that's a perfect square, so we don't know the square root of 75. And what we need to do, we need to change this to a mixed radical. So a mixed radical basically means you go look in these numbers here and see if any of these perfect squares go into 75. And obviously, here is the 25 that goes into 75. So what you need to do, you change this number right here to square root of 25 times 3. It's very important that you change, when you're converting to mixed radicals, you change it to square root of a perfect square times not a perfect square. We can't say, for instance, I could change this to 15 times 5. Yes, 15 times 5 is 75, but this is not a perfect square. This is not a perfect square, so that's not going to help you. So you have to look for a number from the perfect squares that goes into 75, and that's the only way that you could change this into a mixed radical. So next, once you do that, so we change this to 25 times 3. Now I know the square root of 25 is simply 5, so that's not the square root anymore because the square root of 25 is 5. But the 3, I don't know what the square root of 3 is, so that's just going to stay as square root of 3 then. Okay, we'll go to question 2. Question 2 is cube root instead. So just to clarify here, when we write a square root sign like this, the radicand is 2. This here is a 2, so we call that the radicand. But we don't write it when it's a square root. We don't write it. So if we don't write it, that means there's a 2 there, and it means the square root. But when I write a 3 there, that means it's the cube root, and it's the radicand here is 3. Okay. So now the cube root of 40, I have to go look for perfect cubes that go into 40. And as you see, 8 here goes into 40, so I could change this into a cube root of 8 times 5. And that will give me the cube root of 8 is 2. So you should know what the cube roots of all these numbers are. So the cube root of 8, since it's a perfect cube, the cube root of 8 is 2. So I could change that to just 2. But 5, I don't know what the cube root of 5 is. It's you have to use the calculator for that. And that's why we just have to keep it as square root of 5. And therefore now this is your answer. It's 2 the cube root of 5. And here, square root of 80. I mean, you could go, okay, right away I could see 4 is a perfect square that goes into 80. You could do that, but if you do the 4, then you'll have to do this again because that's not the largest perfect cube that goes into 80. The largest perfect cube that goes into 80, I think it's 16 times 5, isn't it? So now I could change this into -3/4, and the 80, I could change that to 16 times 5, which equals, I still have the -3/4 there. However, the square root of 16, since it's the perfect square, I know the square root of 16 is 4, so that becomes times 4 out here. But 5 is not a perfect square, so I cannot square root it, so I'm just going to keep it as square root of 5. Now, this times this, when you multiply a number times a fraction, you could just cancel that number with the bottom of the fraction. And therefore, your final answer for this is -3 root 5. How about here? So square root of 81, x to the 6, y to the 7. See, the 81 is a perfect square already, so you don't have to change it to any numbers. Since it's a perfect square already, then you know that the cube root, sorry, you know the square root of 81 is going to be 9. And x to the 6, when you're square rooting a variable with an exponent, you only, like if you want to square root x to the 6, it just becomes x and then half of the 6, which is 3. And that's how you square root it. Y to the 7, you cannot have the 7 here because it's not a perfect square. Sorry, you cannot have the 7 here because 7 times half is going to give you a decimal. So what you need to do to the y, you need to change it into y to the 6 times y. Now you see how y to the 6, you could half the 6 and therefore it becomes y cubed. But the 1, you cannot have it, so that's just going to stay, the 1 on top of the y, that's just going to stay as square root of y. So whenever the exponent is even, then it's the variable is a perfect square and you could square root it right away by halving the exponent. But if the exponent is not even, when you're doing square root, the exponent on the variable is not even, then you have to change it to y to the 6 in this case times y. If this y was y to the 13, then you change it to y to the 12 times y, just to clarify this a little bit further, because the square root of y to the 12 just give you y to the 6, as I mentioned. You're just halving the 12 when you're square rooting a variable with an even power when it comes to square root. Okay, and that's the final answer for this. Now this one right here, this here, it's a cube root. Yeah. So I'm gonna look here and see, is there a perfect cube inside here? So I could do this first. See x cubed here, it's a perfect cube because the cube root of x cubed is just x. The 3 works, this cube root, the 3 in there works against the 3 in here. So just make it x to the 1. If this was a 6, then the cube root of x to the 6 will be x squared. So it's like you're taking 1/3 of the power, or you're just dividing that power by whatever the radicand is. Like here again, if it's to the 6, there's a 2 there. 6 divided by 2 is 3. That's why I know that I could square root x to the 6. So the cube root of x cubed is x. Cube root of -16, you cannot do it because it's not a perfect cube, and the y to the 4 also is not the perfect cube. You cannot do it either. So what I'm going to do though, I'm going to put the cube root there. The -16, I'm going to change it to -8 times 2. And y to the 4, I need to change it to y cubed times y. Now that would give me the cube root of -8 is -2. I still have the x. And the cube root of y also will be y. So that's done, that's done. And then you have the cube root of 2y. This 2 and this y, you cannot cube root them because they're not perfect cubes. To give you an example, like if it's a cube root of x to the 17, for instance, you need to change that into cube root of, because that's not a perfect cube, but if you make it x to the 15 times x squared, then see how the 15 divides by 3? Then that becomes x to the 5, because 15 divided by 5, 3, and then it's cube rooted, because now that becomes perfect cube, but the x squared, you cannot cube root that, and you just leave it as cube root of x squared. So just to clarify that a little bit further. Okay, so let's move on to the next question. So here's further questions. Now simplify. So just know when you're adding and subtracting radicals, you could only add them and subtract them if they are like terms. What that means, it means if the thing under the radical is the same. So definitely we cannot add these yet, but what I'm gonna try to do is change this into a mixed radical, both of them, and see if we're gonna have the same or like terms after that. So 28, that's definitely the largest perfect square that goes into 28 is 4, so that's gonna be 4 times 7 under the square root plus, and in the 175 is 25 times 7. Now square root of 4 is 2, and then this 7, you cannot square root that because that's not a perfect square, so 2 root 7 plus the square root of 25 is 5, and we cannot square root this 7 because it's not a perfect square. Now see, because they're like terms now, both of them, they have a radical of 7 or a square root of 7, then I could add them by adding the coefficients. So 2 plus 5 here is 7, so it gives me 7 root 7. How about here? Here we're gonna have the same approach, so x is not a perfect square, so we cannot do anything about that. But the 8 and the 18, I could change that into mixed radical. So 5 square root of the 8, I could change that to 4 times 2, and I still have the x underneath the radical, minus 3, and I still have the square root of 18, which I'm going to change to 9 times 2, and I still have the x right there. Now, square root of 4 is 2. You multiply that 2 into the 5, you get 10. So that's 10. And you still have this 2 and this x, they're not perfect squares, you just keep them in there. Minus the square root of 9 here is 3. You multiply it into this 3 outside, it gives you 9. And the 2x, they're not perfect squares, so you cannot square root them, keep them underneath right there. And this here, now they become like terms because what's under the radical, both are the same, so they're like terms. So you just add the coefficients, and here you're subtracting. 10 minus 9 is 1. So that will be just 1 root 2x, and you don't even have to write the 1, so just root 2x. Yeah, so I think I forgot to write part of that question right here. And this one is, so we have 20x underneath here. Now here, again, we don't have like terms, so we cannot add them. I'm going to simplify inside first and see if we're going to get like terms. So to do that, I'm just going to write that as 3x. And the 20, I'm going to change that into the perfect square that goes into 20 is 4. So 4 times 5. And I still have the x lingering along. Minus here, the perfect square that goes into 24 is also 4. That's times 6, and I still have the x right there, and I'm just going to square root that still. Plus 45, I know the perfect square that goes into 45 is the 9 right here. So that makes it 9 times 5. And the x cubed, I have to change that into x squared times x. Why did I do that? I'll talk about this in a bit, but square root of 4 here is 2. 2 times 3x is 6x. And I still have root 5x underneath. Minus square root of 4 is 2. And I still have the 6x underneath because none of them are perfect squares, so I cannot do anything about that. Square root of 9 here is 3, so plus 3. I changed that to x squared times x. Remember how I said there's a 2 here? If that 2 here and that 2 divide, then I could square root the x squared, because the square root of x squared is a perfect square. So when I square root it, I just divide that 2 by that 2, and it gives me 1. So that would just give me x to the power of 1. Don't have to write the 1 in there. But the 5 and the x are not perfect squares, so I'm just going to keep them underneath there. Now, the only like terms I have here are these two right here, because the radical is the same underneath, and also there's a 3x here and a 6x there. If that x wasn't there, it was just 6, and here 3x, they're not like terms anymore. But because they are, both of them have x's and both of them have 5x under the radical, then the like terms, so 6x plus 3x is 9x. And you keep the 5x the same. You never add what's under the radical, you just add the coefficients. And minus, I still have the 2 root 6x. Yeah. This last question here with this perfect cube. So I cannot, same thing, cannot add or subtract unless I have the same thing under the radical or under the cube root. Okay. So here I'm gonna start seeing if I could change these into mixed radicals. So it's the cube root of 16. Definitely 8 is a perfect cube that goes into 16. So 8 times 2. minus the cube root of 54. 54, definitely, I know 27 goes into 54 2 times. Now 8 is a perfect cube. The cube root of 8 is 2. You multiply it in here, that's 6. And you still have the cube root of 2. Minus the cube root of 27. So the cube root of 27 is 3. And I still have the cube root of 2 because I cannot cube root of 2 since it's not a perfect square. Sorry, perfect cube. Now these are like terms, so I just subtract 6 minus 3 is 3. And I still have the cube root of 2. Okay, so I think I'm gonna keep it here for this, and tomorrow what I'll do, I'm gonna do multiplying radicals and foiling, also rationalizing denominators. So we're gonna do that as well, and then solving the radical equations. So that's what I'll do tomorrow. So hopefully this helps you get into radicals. One thing I'll do before I leave this, because I kind of skipped it. So I'm just gonna erase some of this and I'll show you. So if I say change to entire radical, what that means, it means the opposite of what you're doing here. So if you have this, you want to make it this. That's what it means. So if you have 2 root 7, you want to make it 2 root 28. How do we do this? So if we have, let's say, 3 root 5, and they say change it to a mixed radical, all you need to do, just square the 3, which gives you 9. Or just say to yourself, 3 is the same as the square root of 9, isn't it? Because square root of 9 is 3. And you still have the square root of 5. Multiply them, and you get root 45. If it was cube root, so let's say 2 cube root of 4, and they want you to change that into entire radical, then you say 2 is the same as the cube root of 8. So you could change the 2 to cube root of 8. And then you still have the cube root of 4. And then you multiply that and you get cube root of 32. So that's how you change from mixed radical to entire radical.